There we go.
Okay. So yes, hello and welcome. I am Perry Avery, visiting scientific specialist in emerging contaminants at the Illinois Sustainable Technology Center, which is a part of the Prairie Research Institute at the University of Illinois. As a land grant institution, the University of Illinois at Urbana-Champaign has a responsibility to acknowledge the historical context in which it exists. In order to remind ourselves and our community, we begin this event with the following statement. We are currently on the lands of the Peoria, Kaskaskia, Piankashaw, Wea, Miami, Mascoutin, Odawa, Sauk, Muskogee, Kickapoo, Potawatomi, Ojibwe, and Chickasaw nations. It is necessary for us to acknowledge these Native nations and for us to work with them as we move forward as an institution. A few housekeeping items before we get started. Today's webinar will be recorded. The recording and the slides will be available for viewing online in about a week. I'll be sending an email out to everyone who registered for the webinar once they are available. Everyone will remain muted for the entire webinar. You can type in your questions at any time through the Zoom Q&A feature. You will be able to upvote questions you like within Zoom Q&A using the thumbs up button under the question. I will be recording the questions to the speaker at the end of the webinar. At that time, the most popular questions will be asked first, followed by questions in the order they were received. If you have technical difficulties, please send me a private chat message. Also, if you need proof of attendance for continuing education credits or for any other reason, please send an email to perrya2@illinois.edu. So with that, I'm very pleased to welcome today's speaker, Richard Graves. Richard is the director of the Center for Sustainable Building Research and an associate professor in the College of Design at the University of Minnesota. From 2012 to 2014, he was the executive director of the International Living Future Institute, leading the operations and strategic efforts around all of the Institute's signature programs. His research focuses on regenerative design as a fundamentally new approach that must be required of architecture across scales, from the building to the neighborhood to the city, to achieve sustainable and resilient urban development in a dynamic world. The floor is yours, Director Graves.
Great, thanks, Barry. Yeah, and thank you for having me here today. And I'm going to talk about the work that we do at the center on embodied carbon, and how it relates to kind of a challenge for the built environment, strategies that any design team can take, and then also the potential for future guidelines around embodied carbon. Before I get started, I mean, just as a bit of context, the center's work here in Minnesota, we manage a thing called the Minnesota Sustainable Building Guidelines, which is a set of guidelines that are used for all state-funded construction. So that's about 30, 40 projects a year. And the guidelines have been in place actually since 2000. They predated the LEED rating system, and some of the way our guidelines were put together were used as kind of a source on how how to put rating systems together. And embodied carbon has actually been a part of the work of those guidelines since the beginning. The center and the projects have a long history of doing whole building LCAs and doing work with Athena on some of their embodied carbon tools. So that's sort of the grounding of our work. And then we continue to kind of do additional work, think about upgrading that work, and I'll show you some of that work today. So that's just some some important context before I get started. The other thing I will say is I'm going to go through a series of slides, kind of talk about embodied carbon and strategies and processes you can take. I'm also going to be mindful of the clock, so as I get towards the end, I might kind of click through a few things to leave plenty of time for questions. So embodied carbon. So and why is it important? So embodied carbon is the energy and therefore the carbon emissions that are used to, to make the building materials and products and other things to create the built environment. And that's embodied carbon for what's called vertical construction, the building of buildings and those things. But we also have embodied carbon in the built environment in horizontal construction, or roads, bridges, and other things. So, and if we look at kind of CO2 emissions by sectors from this report from 2019, typically the numbers you'll hear for the built environment are around the operational energy portions, somewhere around the 20-ish percentile range. However, the carbon within building materials is about 8%. Then it's also the embodied carbon of a material is also going to show up in the 22% of industrial emissions. And then some of it also within the 17% of transport and, moving materials from where they're manufactured and where materials are extracted to, to get them into whatever we're creating. And then at the end of, the useful life of these things, and they potentially could show up as waste and emissions. So in general, embodied carbon is becoming a more and more important issue that we need to track, and it's hidden kind of across multiple sectors. So that's a challenge that we have. In addition, the buildings that we're making are becoming ever more efficient as codes are getting better, and industries are targeting, a built environment that's close to net zero emissions for new buildings. In other words, buildings that generate all their energy for operations from renewable sources. So because of that, the operational numbers coming down, and that makes the embodied carbon of our construction more and more significant, kind of sort of project by project. And then, so where does embodied carbon, how does it, what are the phases that kind of lead up towards understanding the kind of key life cycle stages of a building? And they come at the product stage, from the raw materials that are extracted, and then the manufacturing processes that occur. This could be blast furnaces used in making steel, things like that. Then the transport, and transport actually can happen, all through these phases. So that's something to keep in mind. Then there are the activities involved in constructing whatever it is we're making, and the embodied carbon used there. Then we get into the use phase of a building, and that the use phases of buildings both have operational carbon, or in other words, the energy used to heat and cool, and for people to charge their phones and do things like that. But we also have maintenance and repair of things within buildings during their use phase, and that's additional kind of embodied carbon. And then at the end of life, we have the kind of deconstruction, demolition, and then whatever waste in their embodied carbon numbers there. So when we look at across the useful life of a building, you have these kind of initial spikes of embodied carbon at year zero, or the kind of upfront embodied carbon of products and the initial construction. Then then a building will have its sort of annual operational carbon that's ticking along, and hopefully that's going down over time. Especially as our electric grids are becoming more and more powered by renewables. Hopefully those carbon emissions will be reducing wherever you are. It's often not a straight line like this graph shows, but that's a whole nother thing. Then we get to certain renovation and maintenance phases, where there'll be other smaller spikes of embodied carbon that come and go, and then, continuing into the future. So it's important to kind of think about how all those pieces fit together. And we have different tools to address these different sources of emissions in our buildings. So for embodied carbon, two tools that I'll talk about are whole building LCAs, and what's starting to become known as buy clean initiatives, or another way to talk about that are environmental product declarations, are a review of the embodied carbon in the supply chain of a product. And so those are two tools to use to get at embodied carbon reductions. And then the high performance building scenarios, or reducing operational carbon. The tool we use here in Minnesota is a thing called Sustainable Buildings 2030. That's based upon Architecture 2030. It's an operational carbon standard or target that we have that is targeting all new buildings to be net zero by 2030. So some type of initiative like that is the tool to use. Building performance standards are kind of the national wide terminology for some of these things, and that's another tool to get at the operational carbon. But both things are important, and understanding how they fit together are important to consider. The other thing that's important is, in the phases of a design project, you need to use different tools at different phases. So during pre-design, when you're conceiving of a project and what systems you're going to use, are you going to have a concrete structure or a steel structure or a wood structure? That's when a lot of the system level decisions are being made, and there's a high ability to influence life cycle emissions. And then in the later stages, design, construction, and use phases, other tools are more important or more useful. So in other words, in the pre-design and early design phases, whole building life cycle assessments are a great tool to kind of get at doing some system level comparisons and making those choices. And then once those are made during construction, that's when a procurement policy, some places known as buy clean, using environmental product declarations, that's when you start to use that tool. You've decided to do a steel structure, and you want to know the steel that you're using is lower embodied carbon steel than some other steel options you might be considering. And that's how those two tools fit together. And we have authored a number of reports now, kind of looking at how do we put all these together for construction work here in Minnesota, in terms of how to have kind of a comprehensive strategy for using whole building LCAs and environmental product declarations has been something we've done a couple of times. So it's also important to look at the hierarchy of decisions that you need to go through as you're making these decisions. The first is, should you build a new project, or is there an ability to do a renovation? So the most important decision in the hierarchy is, is there a possibility to do building reuse for a project? And then once that decision's made, that's when a whole building design or whole building LCA can be used to optimize some of your decisions, things like structural choices, those kinds of things. Then, from there, you can make some decisions using whole building LCAs. You can even do some sort of assembly level optimization. From there, you then look at material substitutions that you can use environmental product declarations. And that, is how you can kind of make all these decisions sort of fit together. And the American Institute of Architects has published a series of handbooks and toolkits on how to use what are whole building LCAs and how can you use them during a design process. So I'd encourage everybody to look at some of those resources. And within that, they really sort of define which are the which operational or which life cycle stages are considered, when you're going through a whole building life cycle assessment. So typically they are kind of cradle to grave kind of assessments to make these reviews and system level decisions. That's important, and that's actually something that you have to control for when you're doing some of this modeling, to make sure whether it's a whole building LCA or it's the environmental product declaration, you have kind of the same life cycle stages assumed as you're doing a comparison of one system versus another in a whole building LCA, or one product versus another in an environmental product declaration. So, and there's a series of, and I won't go through all this detail, but this slide shows a number of the kind of physical and life cycle scope controls that are put in across different systems when you're doing whole building LCAs. So that's important to keep in mind. That's still sort of a work in progress. But some of the kind of big recommendations that came out of the AIA toolkits are to use whole building LCAs to look at the possible savings from building reuse, to identify hotspots of projects for particular materials early in the design process, to estimate the whole building carbon footprint of a project, and to compare different scenarios. One design scenario versus another might have a different carbon footprints, both at the building design level, but also down to the system level. Those are all things to use whole building LCAs for. Environmental product declarations are better used to look at comparing the carbon footprint per unit of two functionally equivalent products. In other words, compare one steel thing, or steel section that you're using in your structure versus another steel. That's how you can use environmental product declarations. You have to have functionally equivalent units with equivalent product category rules. So it's great for steel section versus steel section. Not as good to compare kind of steel versus concrete or something like that. The whole building LCA tools are better for those sorts of things. And I think I'll skip through some of these things. So there's also a number of kind of discussions or reviews sort of looking at benchmarking the values that we get out of some of these tools. And here's some examples from the Carbon Leadership Forum and some other initiatives that are important to kind of consider as you're looking at what's the level of data that you get from some of these systems. And you get one challenge with LCAs is that there's a lot of they're very good for relative comparisons of one material versus another, and that's what they're good at. Sorry, hold on one second. That's what they're good at. They're not like a nutrition label, so you can't get kind of absolute accuracy of data in these systems, so that you can feel like you can have a nutrition label with embodied carbon data. So good for relative comparisons, not so good for absolute data, and that's just a reflection of the LCA data sets. And maybe there'll be some questions about that we can discuss at the end. So just click through some of these things. So here's some just examples of, these are some examples of how we've integrated embodied carbon within the design phases of our Minnesota Sustainable Building Guidelines. So we asked teams during pre-design to put together a whole building LCA. We're also working on how we're going to use EPDs during the construction phase. But right now, we have 3 paths teams can take. They can do the whole building LCA approach, or an assembly level or a material level LCA approach. And we actually have them, we basically collected data for a long time. Now, what we're having them do is show that they can make a baseline building with their whole building LCA and target a 10 or 20% reduction in embodied carbon emissions as our current set of guidelines that we're doing now. We do that at the whole building assembly or product level. But we're working on some of the next phases of these guidelines. And we have tracked for almost 20 years now whole building LCAs on a number of projects. And this was a review that was done kind of looking at a sampling of those projects where we had 42 projects where we had whole building LCAs, and there were a range of sizes of projects. Most of our projects are doing whole building LCAs, and some are doing material level, and then fewer still are doing assembly level whole building LCAs. The tools projects are using, as most of our projects, we have a long history of using the Athena Impact Estimator as our whole building LCA tool. So it's also free. So that's the tool that most teams are still using to do this work. However, we've opened it up so teams can also use Tally, which is integrated with Revit. So we're starting to see more teams use that as a tool. And then one-click LCA is another tool some teams are starting to use. Common errors or challenges is projects are confused whether they're exempt from doing some embodied carbon reduction targets, and that is mostly the confusion within some of our renovation projects or new plus addition projects. There's a lot of challenges with people including or not including different life cycle stages, then just basic math errors that some teams make, and then some incomplete documentation. So we're finding kind of a range of what we would love to do, and we're still the research is still out whether we'll be able to achieve this. What we're hoping to have is to be able to find kind of a typical carbon emissions per square foot of certain project types that would allow us to set embodied carbon budgets. We have a median right now of around 20, but there's quite a range in 16 projects that we looked at, and some outlier projects that might just be math errors. But and the Carbon Leadership Forum is also starting to look at, can they set the same kind of embodied carbon per square foot numbers, and they're having some of the same struggles. And then we also would love to connect to embodied carbon emissions and connect them to operational carbon. We've started to do some work in this space. That also is a challenge because in some ways we feel like we're comparing one set of carbon data and the embodied carbon, and because of the error and some of the data sets and the data sources, it's really hard to compare that with the operational carbon, that we have much better quality of data around those carbon emissions. So we'd love to connect them. We've started to look at kind of how quickly, if you spend this much embodied carbon, how many years of operational carbon is that in the operation of a building, but you know, we have some initial numbers, but we're still working on that. So, you know, opportunities in the future is doing some more control measures around modeling so that we can get the, and we have, you know, those are things that we have in the operational carbon space that we just need to start to do a better job of in the embodied carbon space, to control for stages, to control for modeling error and those kinds of things, so that we can harmonize some of that work. And all the while kind of keeping in mind that until we get kind of better data sets of embodied carbon, you know, we're still going to struggle with some of these challenges. And this was a study that was done that was looking at embodied carbon emissions as a percentage of the building lifespan operational carbon emissions. And if you just look at this chart across different project types, they range from the low end of 9% to the high end of 80%. So I would characterize that as all over the place in trying to tie these two data sets together. So, you know, some more work to be done. So, so that's kind of the beginning part, sort of talking about kind of whole building LCAs and that is a tool that addresses the kind of first three phases of the hierarchy of decisions around embodied carbon in a project. Then we get to the kind of last two phases of, you know, we've picked our building, we've decided new versus renovation, we've started to pick some assemblies. Now we're in the optimization phase of picking one material versus another, one product versus another. What's the tool to use to do that? And the tool that has been developed are environmental product declarations. And environmental product declarations are created from the International Standards Organization that creates kind of a standard and therefore quality control around how these declarations are made by product manufacturers. Important in the creation of these, it's a third-party verified standard. The product category rules are really important in environmental product declarations. They create kind of control measures so that you can compare products within the same product category rules. And there are different there are type 1, type 2, and type 3. In general, we prefer the type 3 environmental product declarations because they're third-party verified and quantified to the life cycle of a product, which is really important. And you know, and we even really prefer. This is an example of an environmental product declaration from I can't remember, this is a concrete product. And so this is a type 3 environmental product declaration. And ideally, we really like product level at the point of manufacture. So this gives an exact plant of manufacture for a concrete, ready-mix concrete product to have its environmental product declaration. So you will see it within environmental product declarations. In some industries, you can't get product specific EPDs. We only have, or for the most part, we only have industry-wide environmental product declarations. So within concrete, you can get a lot of product specific ones. Wood products and masonry products, we still have mostly industry-wide environmental product declarations. So that's just a thing that to keep in mind when you think about this. So, and from the report that we did a couple of years ago, these were the numbers of product-specific environmental product declarations around the country. Most of the most of the EPDs right now are in kind of California and the West Coast, or in New Jersey and the East Coast, and those are tracking to buy clean legislations that have happened for the state-funded construction in California and New Jersey, and those were rolled out and requiring EPDs for products used in those states for construction, and therefore the product manufacturers in those areas kind of scaled up and created EPDs to fill in to those construction supply chains. And not as many, we don't have as many here in the Midwest. It's very limited amount compared to the East and West Coast. If we look at the amount of EPDs by product categories, most of them are in concrete, because concrete's seen as one of the hotspots of embodied carbon in construction projects, and so a lot of the legislations have really targeted concrete as the product to require EPDs to look at doing embodied carbon reductions for that product. So, and that's true when you go to the more detailed numbers. Lots of EPDs around concrete, not as many with masonry, steel, and wood products. And then here's what I was talking about before, where there's a number of industries that have created industry-wide EPDs for steel, aluminum, wood. There actually is a unit masonry industry-wide EPD now, I believe. So I think I'll skip through some of this stuff, but this just kind of goes through those individual materials and where are some of those EPDs around the country now. And because of that legislation, because other states, so Washington State and Colorado and Minnesota and a bunch of other states are all considering doing some requirements around EPDs. So you're starting to see kind of an exponential increase in the number of EPDs being created. I've been meeting with some manufacturers here in Minnesota, and we're probably slated to maybe triple or quadruple our number of EPDs in the next couple of years. And I'm sure other states are seeing a similar, growth pattern. In addition, at the federal level, GSA is also considering doing some things around EPDs, which would also create a kind of continue that expansion of the number of EPDs. So here's some slides kind of showing, a number of the federal policies looking at EPDs, and then state policies in California, Colorado, New Jersey, New York, Oregon, Washington, and then proposed programs, expansion of the California program, Massachusetts, and some other states. We also, I think it was in this chart at the time, but we also have a bill in Minnesota to also do a buy clean policy for our construction that's not already included as part of our Minnesota Sustainable Building Guidelines. And then you're also starting to see a number of voluntary programs, both globally from responsible steel certifications and concrete sustainability council work. The 2030 challenge, Architecture 2030 challenge, is looking at setting embodied carbon targets. The C40 clean construction, the structural engineer firms are doing a 2050 challenge around net zero carbon. So a lot of programs coming up more and more that are targeting embodied carbon and setting some targets for those in different industries. So in terms of putting together programs, you know, it's more and more feasible to put these programs together. States or municipalities, you know, you have to consider as you're putting a program together, how are you going to track the data? Are you going to use a national database to track EPDs? How will and who will review them? Can you give manufacturers kind of notice that this will be required in the future, to give them some time to scale up creating EPDs? There are also some challenges around small manufacturers. Small manufacturers might not be able to afford to put EPDs together. So sometimes states and jurisdictions have thought about doing incentive programs for small manufacturers to help them create EPDs. And then there's design team education so that they know how to collect these things, know how to review them and submit them that's needed. But there's a lot of benefits. There are economic benefits to the manufacturers, because, you know, generally any reduction of embodied carbon is also coming with some energy efficiency in the manufacturing process that could save manufacturers some money. There's also a lot of discussion with manufacturers that if they create EPDs before others, that could give them some competitive advantage. And then there's the obvious, you know, environmental benefits to doing embodied carbon reductions within the supply chains. So I'll skip through some of these things. Well, I do want to talk about this a little bit. Well, one challenge is, you know, when you talk to designers and other groups, environmental groups, there's a desire to try to collect everything on a project to address embodied carbon. And, you know, based upon our experience in doing some of these models, I was going to say it's a fool's errand, but it kind of is a fool's errand, where you're trying to get data on everything. And there's a lot of time required to do that. There's a big data set to do that, when really you need to focus on where are the hotspots, you know, within, probably it's kind of back to the 80-20 principle again, you know, probably 80 to 90% of the carbon emissions are in a much smaller set of the materials used in a construction project. And it's much better to put the focus there, do those, work on those products well, rather than to try to connect every little thing. So, you know, most EPD requirements have definitely focused on concrete and steel, and that makes a lot of sense. However, they've started to expand into other materials, and I think that's something we have to kind of think about. You know, what are those other materials? Are they really hot spots, and is it worth our time to get into them? So concrete, steel, definitely important. Wood and some of its benefits for embodied carbon are important to consider. However, should we be looking at wood with EPDs, or is that more the benefits of switching to a wood structure? You're going to track that with your whole building LCA, and maybe it's not as important at the product level. Asphalt might be a material, especially for road construction and bridge construction, to consider. And then, you know, other high impact materials to look at. So, and we're still doing some work there. You know, and after you, and I'll start to wrap here to leave kind of 15 minutes for questions. You know, once you've started to collect environmental product declarations, the next level of discussion that happens is, if we collect a large enough data set of materials across our supply chain, geographically across the country, that relates to the projects we're building in a specific location, if we collect enough of that, can we then set a limit on, if we know our baseline embodied carbon for a particular product, maybe we can set a limit. You know, maybe we can set a limit for that particular product. So some of the voluntary programs, you're starting to have them set some reduction targets for whole projects. And some of these are quite aggressive targets, you know, 45, 65% net zero. I don't even know how you do net zero embodied carbon. Somehow you are going to have to do more operational, you know, you're going to have manufacturing 100% renewably supplied or something like that. So that's something you're starting to see. We're going to have to think through, you know, how do all the sectors fit together to meet our climate change goals, to really have a better understanding of, does some of these reduction targets make sense? Across places that have set policies for embodied carbon across different materials, this is kind of what I was talking about before. You're seeing other materials kind of come in to different policies. But different places are using different methodologies to set embodied carbon limits. And here's just an example of some of those. They're using different data sets and setting limits in different ways. And here's just some examples of those. Using the Carbon Leadership Forum's EC3 tools, one tool some folks are using. Requirements with some maximum carbon emissions for metric tons for steel and glass and insulation values. This is an example of this is from Marin County's requirements, some examples of concrete limits. And, you know, with concrete limits, you really have to look at the design strength and then have a specific limit for that, because that can affect things. So with that, I think we've got about 15 minutes for questions, and Perry, I think I'll defer to you to let me know what questions to go through. So
Yeah, excellent talk. So thank you, Director Graves. And I'd like to remind everyone that if you have a question that you would like asked, please post it in the Q&A chat, and I'm going to read them out loud. And we've already got a couple of questions in here, so I'm going to start with those. First one, what is the difference between 5% industry versus 22% industry on slide number 2?
5% industry, 2%. Oh. And 2%. I don't see the 2% part. Or 22. Maybe they mean the 22%. Yeah, that's a good question. I mean, my guess is the 5% is more on the extraction side of industry, and the 22% is in the the operational energy use, or the energy from the grid used in in factories. But that's my guess. I'd have to double check that to be sure.
Okay, no problem. Next question. It's not really, it's a question. Can you provide a link to your research document?
Yes, I can definitely do that.
Next one. Is there a tool for making the building reuse decision? I'm not sure. You might have answered that one already. Sort of.
Yeah. There are emerging tools. So Architecture 2030 has created a tool. So you're starting to see some tools to make that decision. To be perfectly honest, I don't completely trust any of the tools I've seen so far, mostly because they're connecting operational carbon numbers and embodied carbon numbers that, as I said earlier in my talk, I don't love the data fidelity, if you will, of those two sets, to connect them in such a direct way to make a decision like that. I think we personally need to do, and we're in the middle of doing some of this work, to run through some of those tools to see what we think of the results. You know, some of our initial running the Architecture 2030 tool, it basically said, who cares about reuse? Just build new efficient buildings and we're good. And I don't know that I think that ought to be the right answer. Maybe that is the right answer, but I think we need to do more work. So sorry, that was a long answer. Yes, there are some tools. Beware of the tools and kind of think through how are you making some of those how are you making some of those decisions. So
Okay, fair enough. Next question: if a product can be reused at the end of the useful life, is that savings accounted for in any tools?
Yes, when you're doing an LCA, you can factor that in. You can account for that in some way. It gets a bit complicated of which, like reused for what. How are you going to account for that savings? But you can. That is something you can account for in the LCA tools. So
Okay.
on both ends, well, and quite frankly, on both ends too, because if you're using construction reuse materials in your own project, you can factor that in your whole building LCA as well. So I don't know if that makes sense, but you can do it both in the beginning phase and the end of life phase, because the end of life, if you're reusing something, it might be the beginning of life in your project, and you can account for it in both ways. So.
Okay. Next question. I think this is more of a clarification maybe, but it says kilograms of CO2 per square foot, or CO2 embodied per square foot. Is that in metric and English units? Just confirming.
Yeah, it's a combo of metric for the carbon emissions and square feet for the building area. So it's not great. It's a hybrid of metric and imperial units, but welcome to the US.
Yeah, that happens sometimes. Okay, next question. What are high impact trade exposed materials?
High impact trade exposed?
Mm-hmm.
Not sure what the trade exposed part means. Was that on a slide maybe?
I'm assuming it was probably on a slide.
Yeah. Let me see here. I'm guessing. Yeah, I can't find it right now, but I think what it's referring to, if the person can give a specific slide number, I can look at it, but it's basically trying to here, the high impact trade exposed polymers can consider, yeah, here we go. Major trade exposed. Oh, that's a good question. Yeah, I think there's a word maybe missing there, but yeah, I don't know what that's referring to. Sorry about that.
Okay, fair enough. Moving on. Are there any methods or tools being developed for in practice, or being developed or in practice, that assess the embodied carbon of existing building stock? For example,
yeah.
Completed construction projects.
Yeah, yes, there's so a lot of the same whole building LCA tools that I mentioned and Architecture 2030. The topic is looking at existing stock, and if you reuse those buildings, is that is there a kind of embodied, does that create sort of an embodied carbon, an avoided embodied carbon number that you should consider? And I've seen companies be looking at companies that'll look at that within their portfolio of buildings. And we've also seen that on the kind of campus master planning approach, that if I look at the campus, what do I have as our sort of embedded embodied carbon within the campus that we've already built, we already own, we already maintain it. And if we work with that and don't build new buildings, does that also create some avoided embodied carbon? And I know at the University of Minnesota, we're talking about that right now in our master planning and sustainability planning work. So that's a great point, and it's all the same tools. You're just using it for a different approach, and that is a potentially exciting area to think about. So,
Okay. Next question. Do any LCA tools currently consider sequestration from concrete carbonation over the service life?
yeah, yes, they do. You can input into some of the whole building LCA tools, though I haven't seen. You would have to do that. So some of the researchers here have done work like that, and by substituting out some of the inputs in a whole building LCA, so it's a little bit complicated on the whole building LCA side to do it. You are starting to see that in environmental product declarations, and I think you'll start to see more and more of that within concrete as you start to get new materials used in concrete mixes and other things that will start to get tracked in some of those EPDs. So.
Okay, looks like we've got one more. It seems there's more CO2 emissions in building operation compared to building materials. In building materials, could you provide which materials have higher and which ones have lower? I guess concrete on the upper side and wood on the lower side. Is that correct?
Yeah. So concrete generally, concrete almost. So when you run a bunch of whole building LCAs, that's when you'll find those hotspots. And it almost doesn't matter the project type generally. Concrete's going to be one of those hotspots, either in the foundation or in the structural system. So that's generally the kind of higher material, followed by followed by steel. From there, that's really when, from there it'll diverge at the product, at the project level. What's your next sort of hotspot material? We actually have seen in some of our modeling, rigid insulations can be quite high embodied carbon materials depending upon what they're made of. What else? Some roofing materials and some siding materials can be high embodied carbon. And then generally the lower end materials are going to be the natural materials like wood or straw bale or things like that, because you're actually potentially sequestering carbon in the material in addition to using it in the building. So that's kind of the general range of things. A lot of the stuff in the middle, kind of glass and gypsum board and carpets, is just noise. And it's just noise. Sorry if there are manufacturers in those areas on the call, but it's just not really high or low per se, and they're just generally used in projects, and they're more noise than creating useful strategies around. So.
Okay, awesome. Looks like that was the last question. So once again, I'd like to thank Director Graves for an amazing talk, and all of you for joining us today, and have a great week, everybody.
All right, great. Well, thank you.
Thank you.